Okay, we're going to go over section 11.1. In 11.1, we dealt with circumference and we dealt with arc length. Now, circumference is on your reference sheet. Remember, we can either use the formula 2 pi r or pi times d. And then for arc length, we do the fraction of this circle with the degrees on the top over 360 times our circumference. And you can either use the 2 pi r or the pi d. Okay, we are not filling this whole thing out. This is for you if you want to fill this out to help you study. I'm going to go through and do the practice questions. Okay, in exercises 1 and 2, it says find the indicated measure. It says the circumference of circle D. So in this diagram, this is marked as 24 feet. The 24 feet, since it's over to the side like this, is indicating that it is from B to D. If the 24 was more in the middle, it would be the whole diameter. And that would be clear on your test or on the EOC. It would be more clear as to what that represents. Okay, so circumference, since I know my radius is 24, I'm going to use the formula that says 2 pi r. Okay. I'm going to say 2 times pi times 24, which gives me 48 pi. This would be my answer in terms of pi. If I were to round my answer, that's where I plug in 3.14. So I do 48 times 3.14. and I get 150.72. Okay, and these answers are in feet. So remember, circumference is a length around the outside, so it's not feet squared, it's just feet. Okay, arc length of AB. AB goes from here to here, and this 105 is our central angle. This central angle and the intercepted arc are the same, so we're going to use the 105 to help us get the arc length. This is when we do a fraction, so 105 over 360 times our circumference. And we already found our circumference, so we could plug this in. So 150.72. And the 105 over 360, remember you can use that fraction button on your calculator and just type that straight in. 105 over 360 times. And when you see that change on your calculator, all it's doing is simplifying the fraction for you. Okay, so don't get freaked out that it changes. And we multiply and we get 43.96. And again, this is feet because it's the length of the arc. Okay. Number 3, you ride your bicycle 42 feet. The diameter of each wheel on your bicycle is 18 inches. How many complete revolutions does the front wheel make? We talked about this word revolutions, and that's like one rotation. Okay, that's what revolutions means, which is the same as the circumference because the circumference is all the way around the circle. So we have an issue here because we have 42 feet that we're riding our bike and we have 18 inches in the diameter. So we are going to have to get the same units, but first we're going to go ahead and find what the circumference is for one revolution. Okay, so circumference is pi times the diameter. Our diameter is 18, so we're going to do 3.14 times 18. We get 56.52. And again, this is in inches. Okay. We want to know how many times does 56.52 inches go into 42 feet. So I'm going to need to change this to inches. If I want to change from feet to inches, I have to multiply my feet by 12 since there's 12 inches in a foot. So 42 times 12 gives me 504. So that's 504 inches. This is my total distance. This is one rotation. So I'm going to take the total I'm traveling and divide by one rotation to figure out how many rotations I make total. So 504 divided by 56.52. I get 8.92 if I round. It says complete rotations. So it goes around 8 full times, almost to 9, but not quite. So our final answer for this one is just going to be 8. A mountain bike tire has a diameter of 26 inches. How far does the tire travel when it makes 32 revolutions? So diameter 26, and we have 32 revolutions. So circumference again is pi times diameter, so 3.14 times 26. And we have 81.64. How far does the tire travel when it makes 32 revolutions? So we need to do this 32 times. So we're going to multiply that circumference by 32. Okay, our inch, this is going to be in inches. Okay, so it travels 2,612.48 inches. Okay, continuing with 1.1 practice. It says find the indicated measure. We need to find the diameter. This is our circumference. So we know our circumference is equal to pi times the diameter. So in order to solve, we need to get the diameter by itself. So we're going to divide by 3.14. So 94.24 divided by 3.14. We have 30.01 is our diameter. So if we were to round, we could round to 30. Okay, circumference. In this picture, we have an arc length of 5.5 and in degrees of 35. So remember that arc length is equal to the degrees over 360 times the circumference. So I need to solve this equation. Okay, the easiest way to solve this equation would be to divide by this fraction on both sides. So if I divide both sides by that fraction, which I can do in my calculator, I'll get C by itself because this will cancel out. So in the calculator, we type in 5.5 divided by 35 over 360 and then hit equals. And we've got 56.57 for our circumference. Number 7, arc length. We have a radius, we have the degrees, so we're going to say the degrees over 360. We have to multiply by circumference. Since this is a radius, we're going to use the formula that's 2 pi r. Okay, now we just multiply everything together in our calculators. So 115 over 360. You hit times and you see the fraction changes, but that's just simplifying the fraction. It's not doing anything wrong. Times 2 times 3.14 times 13. And we've got 26.08 if we round. And this is in inches. Okay. Number 8, we have the measure of QR is what we're trying to find. We have the length, but we don't know the degrees. So we need to fill in what we have. We have the length is 26. We don't know the degrees. And this is a radius. Excuse me. So in the circumference formula, we're going to say 2 times pi times the radius. So what can I simplify? So I could simplify first, and I can multiply the 2 and the 3.14 together, and I get 6.28. And now to get rid of this fraction, you multiply by the denominator. So when I multiply both sides by 360, that fraction goes away. So I'm going to do 360 times 26. And I've got 9360 equals x times 6.28 times r. I know the R, I forgot to fill that in, so that's 20. That's my bad. Let me fill that in, it's 20. And I can go ahead and multiply the 6.28 times the 20. So I've got 125.6 times x. And then to get the x by itself, I'm going to divide. Divide both sides by 125.6. So 9360 divided by 125.6. We've got 74.52 degrees for our final answer. Okay, now it says we need to find the perimeter of the shaded region for these questions. So if we look at just this part first. So we're looking at just the part with the straight lines first. Okay, perimeter means we're going around the outside, right? But some of these things are going to help us figure out the measurements that we need. Okay, this distance is 6. So that would mean that this distance here would also be 6, which is going to help us realize that these distances are 3. Because those are 3, we know the radius of our circle is 3. Okay, so that's going to help us because we have this arc length, this arc length, this arc length, and this arc length on the outside. Now, remember that perimeter is just the outside. Okay, so just the outside. So I have 4 curved pieces and I have 4 straight pieces. Those straight pieces are each 6 units. So the straight pieces give me 24. These curved pieces each have this 90-degree mark inside. If I put those all together, they're going to make an entire circle because an entire circle is 360, which is 90 times 4. Okay, so if I add these 4 little curves together, I get one circle. The distance around the circle is the circumference. So 2 pi r. My r is 3. So 2 times 3.14 times 3. So 18.84. That's the curved part. So I'm going to need to put these two together, the straight pieces plus the curved pieces, and I've got 42.84. That would be my total. Okay, for the next one, for number 10, we have this little triangle on the inside, and it's important that these are all marked the same. Because they are all marked the same, we know that there's 60 degrees. Because there's 180 total in a triangle, and if I split it evenly, that means they're each 60. That's going to help me because that means that this part on the outside here is going to be 300 degrees. Okay, and that's going to be the same for all of these. This is the part I'm trying to find. This is 300 degrees, and then this would be 300 degrees. So the 4 is showing me the radius. I have 3 of the exact same pieces, right? So if I found the arc length for one of these circles, I can just multiply my answer by 3 and get my total perimeter. So for one circle, it's 300 degrees over 360 times 2 times 3.14 times 4. So I'm going to multiply all of that together. 300 over 360 times 2 times 3.14 times 4. And I've got 20.93. There's 3 exactly the same as that, so I'm going to multiply my answer times 3. And it rounds to about 63. And we're just rounding on that one. Okay. All right, that is the end of the review for 11.1.